Hey everybody, Francisco with the DevLife. This is the fourth installment of the API series here in the channel. This is probably the most important video because we put to use all the things we've built on previous videos. In this video, we are going to create a web API and incorporate Entity Framework to utilize the database we created on the previous video. Welcome back to the channel. If you're new to the channel, I'm a self-taught developer with over 10 years of experience. In this channel, we create videos with intent for them to become resources for developers. Some videos are technical, and in some videos I share insights that I've gathered throughout my journey as a developer. If you didn't watch our previous videos, you can find links in the description below. Let's get to it.
Okay, so the first thing we gotta do is create a user in our database. And for that, let's go to security. Create new login. We are going to use SQL Server Authentication. Let's call the user car db user. Make this password 123 super secure. Database, and we are going to make sure that this new user has access to the car database as the owner. Okay, so we should be good there. Okay, so this is a step that I forgot to do in the last video, so I just wanted to take care of it. Oh, and by the way, if you haven't watched the last video, there's going to be a link in the description. So you can catch up if you are lost on the steps that we're taking. So the next thing we gotta do is create a new project. This is going to be a web API project. It's going to be an ASP.NET Core project. And it's going to be a web project. Let's call this Cars API. And put this in the C drive. Okay. And let's select place solution and project in the same directory. Let's click create. This is going to be an API project. Let's configure for HTTPS. We don't need Docker. We don't need authentication. Make sure that you select API and not an empty project. This is going to get us there quicker. So let's go ahead and click create. Okay, so now our project is being generated. Okay, so it looks like we have a project. So let's remove this default weather forecast controller. We don't want it here, so let's go ahead and remove that. And let's get rid of this file as well. This is part of this boilerplate. Okay, so I think here we are ready to start. So the first thing we got to do is set up our database connection string. We have to do that in the app settings file. So let's go ahead and double click that. And here, let's add a new section in the app settings called connection strings. And we are going to add a new connection string called CardDB. And for the sake of expediting this video, I have already created a connection string, and this is what it looks like. Okay, so let's go ahead and save that. To be able to use Entity Framework, we have to bring in a couple packages. So let's go ahead and go to the NuGet package manager, and let's search for Entity Framework. Okay, here it it is, and we are going to install it to Parse API. Let's go ahead and install. Accept. Okay, the next package we gotta install, it's called Entity Framework Tools. Here it is. And let's install that one. Okay, and accept. So now the next thing we have to do is execute a command to scaffold or automatically bring in all the tables that we created in our database into this project so we could interact with them from our code. For that, we have to run this command in the manager console. So if you don't see the manager console down here, you can bring it up by going to Tools, NuGet Package Manager, and Package Manager Console. So let me explain this a little bit. So here we are telling Entity Framework to scaffold a DB context using connection string called CardDB. And we want it to output all the models that it creates or it generates into the EF directory. This command here, or this option parameter, that force parameter, what it does is that if you have already brought in a DB context, this will automatically overwrite what you have in that directory. So in case, so let's say that you add a new table or a new column to one of your tables, if you just run this command again, it will automatically override your EF directory. So let's go ahead and run this. Okay, so as you can see, it automatically generated that EF directory and it brought all the tables in that we had in our database. So we had 6 tables and we ended up with 6 models over here. Okay, there's one more step we need to do to be able to automatically use dependency injection. So we have to go to the startup file and we have to tell the application to use the connection string that we set up in our app settings file. Okay, and for that, add a DB context. And it's going to be a CardDB context. Connection string was CardDB. Okay. Okay, so if we build this, okay, we should be able to build okay now. Now we get to the fun part. So let's go ahead and create a controller. And let's call this the makes controller. This is going to be an API controller. And it's going to be empty and it's going to be called makes. Okay, there's one more NuGet package that I like using because this makes it easier to work with JSON objects, and it's one of the most popular ones. Newtonsoft.json, let's go ahead and install that. Okay. Let's create an endpoint that will query the database, and it's going to give us a list of all the existing card makes. So let's go ahead and call this route get all. So this is going to get all makes. let's create a DB context. And this is going to be a CardDB context. And let's bring that namespace in here. Okay. So now let's make a query and get all makes available in the database. We are going to execute this query now. So db make or makes, and we are simply going to get all makes into a list, and we are going to return a 200, meaning a successful response, and we are going to output all the makes available in the database. Okay, so let's go ahead and run this. Okay, let's change this endpoint. Let's call this API makes get all. Okay, let's see, what are we missing? So API controller is called makes, and action. Okay, I missed a couple of things here. We have to specify this controller action accepts HTTP GET requests, and let's specify a route just to make sure that we are good with this. So let's call that get all. Okay, let's try it again. So now let's change this to API makes and get all. Okay, I think I see what's going on here. So it looks like we have to use dependency injection to be able to use the DB context. So, okay, so to do that, let's create a constructor. And this is going to expect a car DB context. We're gonna call that DB. And let's make a private variable here. Let's call that DB. And let's set this to be to okay, and let's get rid of this piece here and this. All right, let's run it again. I'm going to go ahead and update the default launch endpoint or URL here so we don't keep getting this 404. All right, let's go to API makes get all. All right, and let's see if it works now. There we go. So now we are getting data from the database, and if we compare this data with the data we have in the database, it should match. Okay, here we go. We are getting that data here. Let me explain this a little bit, and let me explain why I made this change here. Dependency injection automatically detects that we are expecting to have a DB or a CardDB context instantiated along with the constructor of this controller. And we instructed our application to use this connection string whenever we want to instantiate CardDB context anywhere in our application. Now, the reason why I created this global variable is so we could use this _db, which is our database context, anywhere on these actions here. So the constructor is the first thing that gets called when we create a new controller or any class for that matter. So we are taking advantage of the fact that we'll have the DB instantiated by the time we hit the constructor, and we are just storing that DB context in a global variable so we could reuse it anywhere we want. Okay, so I think this is probably the most exciting piece, because now we were able to get data from our database, and as you can see, it didn't take that many lines of code using Entity Framework, and that is one of the reasons why Entity Framework is so popular, because it literally took, after we configured our database connection string, it literally took one line of code for us to retrieve data from the database, which is pretty cool. I think before using ADO.NET, there was a little bit more work to be able to do this. Let's go ahead and change our settings so we don't keep launching onto the weather forecast controller. So let's go change that here. Okay, launch URL weather forecast. Let's do that. Let's change that to API makes get all. Okay, let's start that. Let's see if it now goes to the correct URL. Okay, so now it's automatically launching to the URL we expect. Now that that's working, let's go ahead and download another tool I like using, and which makes it easy for us to send requests to APIs. Let's go ahead and search for Postman. Let's download the app. I'm going to go ahead and fast forward through the installation so you don't have to wait for it to install. Let's do that. Okay, so the application finished installing. Let's go ahead and open it. Okay, here you have the ability to create collections. So this is a collection of requests that you could save and rerun later whenever you need them. So let's go ahead and create one called car API. So here's where we are going to hold our requests. So let's go ahead and set up the first request. Let's run the application again so we can get the URL. And this is the URL we want. So let's go ahead and copy that. Let's paste it here. We are making sure that this is a GET request. So let's go ahead and save this into the car API and send. Since we are using HTTPS and it's not a valid certificate, it's a self-signed certificate, let's go ahead and disable the SSL verification. That way we don't run into that issue anymore. Okay, so now you can see that we are getting our data, and this is a lot and this UI makes it readable. This UI makes it more readable because it automatically formats JSON responses. Okay, so now that we have that, let's create another endpoint. But in this one, we are going to retrieve only one of the makes. We don't want all of them. Let's say that you are looking for a specific car make and you just want to retrieve that JSON object in your application. So let's go ahead and start off by copying this controller action that we already have set up, and we are going to change a couple things here. So one thing we're going to change is that we're going to change the name of this route, and we are going to automatically tell the API that we are going to also be passing in another parameter on this URL, and that additional parameter is going to be interpreted as an ID. So it will be the ID of the car make. As you can see here on this request, we have a make ID, and we are going to be retrieving the complete object. For example, let's start with Subaru. We will tell the API that we want to return the car make with the ID of 4. So let's go ahead and finish wiring that up. So we have an HTTP GET call. The controller action will be called GET, so it matches the route up here. And here we're going to expect an integer with ID. This query will change. So this will now be make, and in the DB context, we are going to find the record with a primary key of ID. So whatever value we send in here, we're going to use it to do a search, and we are going to return whatever we find. Okay, so let's go ahead and test this. Let's go ahead and run this. Now let's prepare a request here that we can reuse later. Let's say duplicate, and let's rename. And it's not going to be called get all anymore. It's just going to be called get. Okay, and the URL will change to, we're going to remove get all, and we are going to send that /4 at the end. So let's go ahead and test. Okay, so now you see that we get Subaru. We only get one car make as opposed to all of the ones available in the database. So let's change this to, let's say 10, which is something that does not exist. When we do that, we get a no content, meaning that we did not find a match. You know, you can leave it like that. Personally, I prefer to return something different. So let's go ahead and make a slight change here. So let's say that if make is null at this point, let's return a bad request, and let the user know that no data was found. Okay, let's try it again now. So now instead of a 204, as we were seeing here, we should be getting a 400, which is letting us know that we did something wrong and we are trying to request data that does not exist. And there you have it. And this is the message that we are returning here. So as you can see, it seems like we're doing a lot of data searching and interactions with not a lot of lines of code, so which is very, very cool. Okay, so far we have retrieved all the makes. We have retrieved a single make. Now we want to create a make or add a new make to the database. Okay, so for that, we are going to set up a post request, and this will take a little bit more work on our end. This is going to be create a new route. Again, and this is going to be called create. We are not going to be accepting get requests anymore. We want to process only post requests when we want to create a new record. Okay, so this is going to be called, this is going to expect a model, and let's go ahead and generate that model. So let's create a new folder, and we are going to be calling this models. A new class, and we are going to call this make model. Okay, and this model will have one property, and it's going to be make. And since we are working with JSON, the right way of doing this is to say that whenever we work with this property and we need it in JSON format, it will be called make. Okay, so now in the makes controller, we are going to be expecting a make model, and let's just call it model here. Okay, so this is going to take a little bit more work as compared to the other controller actions where we are only returning data and not writing. So here, the first step we need to do is we need to create a make model, or we need to instantiate a model, a make model. This could get a little confusing because now we have make here and we have make over here, but there are two different types of model. One is the one that we just created. This model we will use to receive data when a user wants to create a new make. The make without the model piece or the model part is the one that got automatically generated when we scaffold or when we brought in all of the models from our database. So there's a slight difference there. So hopefully that helps you avoid any confusion here. So this is going to create a new instance of a model that will eventually end up being written to the database. Okay, so we have the new make and we are going to set the make name to whatever the user sends in or whatever comes in the request, in the post request. Okay, so now that we have that set, let's go ahead and tell the DB context that we want to add this model that we just created to the DB context, and then let's tell it to save the changes. So this is going to actually go and write the record to the database. And let's return an OK at this time and return the newly created make, just so we can let the user know that it was created. Let's add one more thing here. We don't have any error checking here, so let's go ahead and check to make sure that the request actually does contain a make, because we don't want to insert something that is empty. So let's go ahead and check if the model make is not null, or actually let's check if the model make is null or empty, and if it is, let's return a bad request and let's tell the user that no make was specified. Okay, let's test this. Okay, so for this we are going to have to create a new request. So let's add a new one. This is going to be a post request. The URL will be create, and for the body, we are going to be sending JSON, and the payload will look something like this. The value we are going to be sending, let's go ahead and add Audi. Okay, let's save this request. Let's make it part of our collection and let's send it. Okay, so as you can see, it went ahead and it wrote to the database the new make that we just sent. So now what happens if we send an empty value for the make? We should be getting a bad request. Let's see. And we do, bad request. No make was specified, which is something good because we don't want to write something to the database that is just going to be a null or an empty string. So you can see that now in the database we have Audi there. There could be more validation that you could add here. And there's actually a framework that .NET has to be able to specify if a certain field in a model is required whenever you want to add more validation. But I guess this is a good point to start. At least what I want to show you is the ability to write to the database. And I think this is a good way to do it. So now the next thing, since we are implementing CRUD, so far we've been able to read, we are able to create, we have to update and delete. So let's go ahead and let's go with an update request. So that is going to be very similar to this action, but this is going to be called update. We're still going to expect for a model to be passed in. We can leave that there. We are going to need to make a change to the make model. Let's go ahead and add a new property to it. And we are going to call this, let's just call it ID. It's going to be an integer ID. Oh, I misspelled public here. To learn how to type. And why is this not being highlighted yet? Well, I guess it's working okay. Okay, and this needs to be updated to update, and here we are going to be checking for the ID as well, not just the make anymore. So this will be ID. And this is going to say no ID specified in case we get an empty ID here. Okay, so the next thing is that we are going to have to pull in the record from the database, so the original record. Let's go ahead and find that record. Makes find model.id. So we're gonna find a car make with the model ID that matches what was passed in the controller. Okay, so now if we don't find a record, then let's go ahead and return a bad request, letting the user know that they probably sent in the wrong ID. But if the make ID was found, we are going to update the make name to the new name that was sent in with the request. Then we are going to attach this record to the context so it gets picked up as a modified record, and then we are going to save the changes. Something's wrong with my computer. Okay, I apologize for that. I had to shut down the virtual machine I'm using, this VM that we created again on previous videos, and I went ahead and added more resources to it because it was just taking way too long to compile and build my my API. So okay, so let's pick up where we left off. So we were working on updating. I think I got the code changes done. I was just getting issues with validations happening in real time, and it was just, the computer got really sluggish. So I think we should be good now. So let's go ahead and run this. Okay, and let's prepare a request in Postman. That, and this one is going to be similar to the post, except it's going to be a put. So let's duplicate this one and let's rename it to update. And it's not going to be a post, it's going to be a put. Let's go ahead and save it. And for the body, let's update the URL here with the endpoint. And for the body, we can send in. So let's say that for Audi, let's actually check the ones we have. So let's say we want to update number 6 to be Dodge instead of Audi. So we are going to be sending in the ID of 6, and we are going to be changing it to Dodge. And let's go ahead and test that. 404 method not allowed. Okay, let's see. What are we missing? And yep, it's completely right. We still have this set to post. So let's change that to put. Okay, let's run it again. And let's send it in. And voila. So now we have, okay, so it says no ID specified, which tells me that we ended up not getting a model ID in the payload here. So let's go ahead and put a breakpoint here. And let's send the request again. Let's see what's happening. Okay, so we hit our breakpoint. And in the model, we are getting ID. Okay, this is a rookie mistake. So here is my logic here is reversed. So I want to return an error only when model ID is equal to 0, not the other way around. So let's go ahead and try that again. Okay, let's send a request and let's double check that we have ID, we have make. Get rid of this breakpoint and continue. And there you go. So now we got a 200, and let's check the database just to make sure. And there you have it. So now there's no more Audi, and we have Dodge as one of the makes. All right, so I think we're making good progress. So far we have read, created, and updated. Now we have to delete. Okay, so that one is very similar to getting a single record. So the way this is going to work is copying that, and its request is going to be a delete, and here is going to be again delete here, and update delete here. And we're also going to be searching for a record called make, and we are going to delete record. So we are going to make a query to remove make, and then we are going to save the changes. Just a few lines of code, and then you can update records in the database so easily. Okay, so let's go ahead and run this, and let's set up a request for us to use. So let's start with a copy of this one. Let's duplicate that one. Let's rename it to delete. Let's open it. Let's change the HTTP verb to delete, and let's update this URL here to delete. And let's delete Dodge, which is the last one we added. So that would be ID number 6. Okay. So we are going to pass ID there, ID 6. Save it. And let's put a breakpoint just to make sure that everything goes well here. Okay. And let's send the request. Okay, we hit our breakpoint. We have ID of 6, so let's go to the next line. Okay, looks like we found our record, which is Dodge. So we don't have to return this error here because we did find a record, and we are going to remove it from the database. And I think here, well, I think we can return it, but we know that it does not exist in the database anymore. So if we call this endpoint now, we shouldn't see the make ID of 6 anymore. So let's go ahead and send it. And there you have it. The last one is Lexus. Okay, so as you can see, I think we have completed it. I think we were able to make all the different CRUD operations, and you could reuse these payloads with the collections that we created here. Now, one thing that I do want to mention is that this is probably not best practice as far as having interactions with the database at the controller level. You probably want to maybe follow the repository pattern and create services to interact with your data. If you ever work as a developer professionally, you shouldn't see any database interactions at the controller level. So that's just something that I want to mention. It's just something that I want to mention so you don't believe that this is, best practice. It is not. This is just for beginners who want to be able to start playing with databases and being able to make requests to delete and remove data. Now, I think we're about a half hour or so into the video by my calculations after I finish editing. I think now that you see what we did with the makes controller, you sort of get the idea of what needs to be done for the rest of the tables in our database. You are probably imagining that you probably need a body types controller, which will also do the same operations as the makes.
just to keep this video shortened and to not be repetitive, I'm not going to go ahead and include or create controllers for each one of these tables in this video, because we are going to end up with like a 2-hour video with the same things happening over and over again. If you found the video useful, please subscribe and leave us a like. It really helps us with the algorithm, and it keeps us motivated to create new videos. So please leave a like, and catch you in the next one.